Right now, at this exact moment, something is hiding behind our Sunday. On October 29, 2025, at 11:36 UTC, the interstellar object designated 3I/Atlas will reach perihelion, its closest approach to our star, at a distance of 200 to 3 million kilometers. On that precise date, it will be positioned directly behind the Sun from Earth's perspective, completely unobservable from our planet during the most critical phase of its journey. This is not coincidence. This is orbital mechanics meeting something we don't fully understand. And here's what makes your spine tingle. At the exact moment it disappears from our view, this object, at least 5 kilometers in diameter, larger than Manhattan Island, will be receiving 33 gigawatts of solar power on its surface. That's more than a third of the total power generated by 94 operating commercial nuclear reactors in the United States. But power for what? Let me be clear from the outset. I am a theoretical physicist. I follow evidence, not speculation. I have spent decades working with equations, with data, with the mathematics that govern our universe. And the data on 3I/Atlas is keeping me awake at night. The Atlas Survey Telescope in Rio Hurtado, Chile, first reported observations of this object to the Minor Planet Center on July 1, 2025. Pre-discovery observations extend back to June 14 from 3 different Atlas telescopes worldwide and the Zwicky Transient Facility at Palomar Observatory in California. When astronomers first calculated its trajectory, traveling at 137,000 miles per hour, 61 kilometers per second, they noticed something extraordinary. The object was anomalously bright for its distance, 4.5 astronomical units from the Sun, too bright. Initial calculations suggested a diameter of approximately 20 kilometers, assuming typical asteroid albedo. That size estimate created an immediate problem. Think of it this way. Imagine you're fishing in the ocean. You've caught 2 minnows over the past 8 years. Then suddenly you pull up a whale. The statistical probability doesn't add up. Based on the total reservoir of interstellar asteroids and the discovery rate over 5 years of intensive sky surveys, detecting a 20-kilometer object has a probability of 0.0001. We should have discovered approximately 100,000 objects the size of one I/Oumuamua, which was just 200 meters across, before finding something as massive as 3I/Atlas. Yet we only detected 2 interstellar objects previously, Oumuamua in 2017, 2I/Borisov in 2019. Both were comparatively tiny. The Hubble Space Telescope captured detailed images on July 21, 2025, when the object was 277 million miles from Earth. NASA and ESA announced these observations on August 7. What Hubble revealed changed the game. A teardrop-shaped cocoon of dust, a coma consistent with comet activity. Observations as of August 20th indicated the upper limit on nucleus diameter is 3.5 miles, 5.6 kilometers, though it could be as small as 1,444 feet, 440 meters, across. Most scientists breathe easier. It's a comet, natural, explainable, case closed. Except the case wasn't closed. It was just beginning. The James Webb Space Telescope performed spectroscopy on August 6, 2025, using its NIRSPEC instrument. The data showed carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice being released as expected from a warming comet. But here's where it gets interesting. The carbon dioxide to water ice ratio measured 8 to 1. 8 to 1. That's among the highest ever recorded for any comet, solar system, or otherwise. It's literally out of this world. It suggests formation conditions radically different from anything in our local neighborhood. Fine, comets from other star systems should be different. That's expected. But then came the metal. The Keck 2 telescope in Hawaii conducted spectroscopic observations in August 2025. What they found defies conventional comet physics. Strong nickel emission lines extending several hundred kilometers from the nucleus. And here's the kicker, no detectable iron. Let me repeat that. Nickel without iron. This emission pattern has never been observed in any known comet, including the interstellar comet 2I/Borisov, which showed typical nickel-iron ratios similar to solar system comets. The Keck team proposed a natural carbonyl process similar to industrial nickel refining through nickel tetracarbonyl, potentially forming and decomposing close to the nucleus. But the surface temperature of comets is too low to allow sublimation of refractory minerals containing these metals in the first place. The Very Large Telescope in Chile provided additional data using its UVES spectrograph. The ratio of nickel production to iron production in 3I/Atlas sits in a region of parameter space occupied by no other observed comet. The data point, represented as red squares on the diagnostic plot, lies isolated, separated from every other comet measurement, represented as diamonds of various colors. It's an outlier, a significant outlier. Think about this as a cosmic fingerprint. Every object in space carries a chemical signature that tells us where it came from, what it's made of, how it formed. Nickel without iron at these ratios is a fingerprint we've only seen in one place before: human industrial processes. The carbonyl pathway that produces pure nickel compounds is used in terrestrial metal refining. Does that mean 3I/Atlas is artificial? No, it means we don't understand the chemistry occurring on this object. Let that sink in. Now let's talk about geometry. Hubble's July 21st image showed something unusual: an anti-tail, a jet pointing toward the sun, not away from it. This narrow extension, 10 times longer than it is wide, appeared on the sunward side of the nucleus. Comets develop tails that stream away from the sun due to solar radiation pressure pushing gas and dust outward. Sometimes they develop anti-tails, but these are optical illusions, perspective effects caused by Earth's viewing angle relative to the comet's dust trail left in orbital space. But 3I/Atlas's anti-tail is not a perspective effect. It's physically pointing at the Sunday. Spectroscopic data from multiple observatories confirm that gas and dust are being ejected sunward against the pressure of solar radiation. The mechanism is unknown. Let me translate this into an analogy. Imagine standing in a hurricane. The wind is blowing at 100 miles per hour, pushing everything away from the source. But you see a flag flying directly into the wind, streaming toward the storm's center. That's not how physics works, unless something else is generating thrust in that direction. ESA's Mars Express and ExoMars Trace Gas Orbiter attempted observations when 3I/Atlas passed Mars on October 3, 2025, at a distance of approximately 30 million kilometers, 29 million kilometers in some measurements. The ExoMars TGO's CASIS instrument captured a series of images showing the comet as a slightly fuzzy white dot among streaked stars. The imaging system, designed for Mars's bright surface at distances of hundreds to thousands of kilometers, struggled with a much fainter target millions of kilometers away. The images revealed little detail, no structural information, no resolution of surface features, just confirmation of presence. But absence of evidence is not evidence of absence, and there were 7 other spacecraft with eyes on this object during its Mars flyby. NASA's Mars Reconnaissance Orbiter, with its high-rise camera capable of 30-kilometer pixel resolution, ESA's Mars Express with Omega and SpyCam spectrometers, multiple observation attempts across different wavelengths and instruments. The fact that we haven't seen high-resolution images released publicly doesn't mean they don't exist. It means the data is being processed, analyzed, reviewed, or it means what was captured is being carefully evaluated before public release. Here's the terrifying part. The trajectory of 3I/Atlas is aligned to within 5 degrees of the ecliptic plane, the flat disk defined by Earth's orbit around the Sunday. For an object arriving from interstellar space with a random orientation of its orbital angular momentum vector, the probability of this alignment is approximately 0.002, 2 in 1,000. Not impossible, but highly improbable. The object is on a retrograde orbit, moving opposite to the planet's direction. It approaches from above the ecliptic, crosses the plane, reaches perihelion behind the Sun, and will pass 0.65 astronomical units from Venus on November 3rd, 1.83 astronomical units from Earth on December 19th, and approximately 0.31 astronomical units from Jupiter, 46 million kilometers, around March 16, 2026. These are close approaches, not dangerous, but close enough for detailed observation by spacecraft already in position. Why does this trajectory matter? Because if you were designing a path through our solar system to observe multiple planets while conserving fuel, this is exactly the trajectory you would choose. The gravitational assists, the viewing angles, the arrival time allowing Earth observation during the most active approach phase. It's optimal. Let me give you another number. 3 I/ATLAS is at least 1 million times more massive than 1 I/Oumuamua and approximately 1,000 times more massive than 2 I/Borisov. A new analysis tracking 4,022 observations from 227 observatories worldwide between May 15 and September 23, 2025, measured the object's deviation from a purely gravitational trajectory. The residuals in sky coordinates, right ascension and declination, averaged across all observations, showed zero non-gravitational acceleration within measurement uncertainty, 0. For a comet losing mass at the rate confirmed by Webb telescope measurements of water and carbon dioxide outgassing, zero non-gravitational acceleration means the object must be extraordinarily massive to resist the rocket effect of gas jets. The minimum mass calculated from this absence of acceleration is 33 billion tons. 33 billion tons with a nucleus diameter larger than 5 kilometers. This is anomaly stacking. Each individual anomaly, considered alone, can be rationalized, explained away, attributed to unusual but natural conditions. Bright at discovery, comet outgassing. Unusual chemistry, different formation environment, anti-tail, unknown sublimation process, massive size, statistical fluke, ecliptic alignment, coincidence. But when you stack these anomalies together, when you multiply their individual probabilities, you approach an improbability that demands attention. Let's be methodical. Let's consider 3 interpretive frameworks, 3 scenarios that fit the observational data. Scenario 1. Natural comet from an exotic environment. 3 I/Atlas originated in a planetary system where metal-rich collisions created debris fields with unusual chemistry. Perhaps a planet with high nickel content was destroyed, creating a population of comet nuclei enriched in nickel compounds. The high carbon dioxide ratio indicates formation beyond the carbon monoxide ice line in a system with different stellar luminosity or protoplanetary disk chemistry than our Sunday. The anti-tail results from asymmetric sublimation driven by subsurface pressurization and directed gas release through vents or fractures aligned by chance toward the Sunday. The large mass is simply the luck of the draw, the one massive interstellar comet that happened to pass through our detection zone during our brief window of advanced observational capability. The ecliptic alignment is coincidence, a roll of cosmic dice landing on an improbable but not impossible outcome. This scenario requires no new physics. It requires only unusual conditions and good fortune in timing. It is the conservative interpretation. It is probably correct. Scenario 2, warning beacon or navigational marker. 3 I/Atlas is a deliberately altered object, possibly natural in origin but modified, carrying substances or structures designed to be detectable across interstellar distances. The nickel emission without iron acts as a spectroscopic signature, a pattern that says, "Look here, this is not natural, pay attention." The sunward jet provides active orientation control, maintaining stability or directing outgassing for trajectory correction. The large mass houses mechanisms or payloads protected during the long interstellar journey. The ecliptic alignment is intentional, placing the object on a path that samples the habitable zone of our solar system, passing near rocky planets where life might exist. It arrives, performs its observations during the perihelion phase when power is maximum, and departs, carrying data back to wherever it came from. Or perhaps it doesn't carry anything back. Perhaps it simply transmits. This scenario requires technology. It requires intention. It requires the existence of another civilization capable of interstellar engineering. It is speculative, but it fits the data. Scenario 3, diagnostic probe. 3I/Atlas is not merely observing but actively testing. The chemical emissions are deliberate releases, experiments to measure solar system composition by releasing tracers and observing how they interact with solar wind, magnetic fields, planetary atmospheres. The anti-tail is not sublimation, but thrust, small course corrections executed during approach to refine trajectory for optimal planetary flybys. The timing of perihelion behind the Sun provides a window for maneuvers unobservable from Earth, the so-called Oberth effect window, where velocity changes are most energy efficient. The massive size contains not ice and rock, but systems, instruments, possibly even miniaturized probes that will be released near perihelion to take advantage of solar gravitational assist for dispersal toward planetary targets. This scenario requires advanced capability. It requires that we are being studied. It fits the data and explains the timing. How do we evaluate these scenarios? With evidence, with more observations, with careful methodical science that follows the data wherever it leads, even if it leads to uncomfortable conclusions. The International Asteroid Warning Network, a worldwide planetary defense collaboration, announced on October 21, 2025, the date of 3I/Atlas's solar conjunction, a dedicated observation campaign running from November 27 through January 27, 2026. The stated purpose is improving astrometric measurements and orbit predictions for cometary bodies. But read between the lines. IAWN is a network designed to monitor potentially hazardous objects. 3I/Atlas poses no collision risk. Its trajectory never brings it closer than 1.8 astronomical units to Earth, approximately 170 million miles. So why the campaign? Why the workshop on measurement techniques? Why the coordination? Because 3I/Atlas is the first interstellar object ever targeted by IAWN campaigns. Because the scientific community recognizes that this object is special. Because we need to know what happens next. Let me give you the countdown, the critical dates, the moments when we will learn more. October 29th, 2025, 11:36 UTC, perihelion, 3I/Atlas reaches its closest approach to the Sun at 1.356 astronomical units. It is behind the Sun from Earth's perspective, unobservable. If anything unusual is going to happen, if any maneuvers are going to occur, if any objects are going to be released, this is the optimal window. Maximum solar power, maximum velocity. Minimum observation. We won't see it, but other spacecraft might. November 3rd, 2025. Close approach to Venus, 0.65 astronomical units. ESA's Venus Express mission ended in 2014, but other observations from ground-based telescopes and space-based platforms will track the object as it passes our sister planet. November 11th, 2025. 3I/Atlas re-emerges into Earth's morning sky, observable again from ground-based telescopes. This is when we see what came out of perihelion. This is when we check if the object is still intact, still following predictions, still behaving like a comet. November 25. ESA's Jupiter Icy Moons Explorer, JUICE, begins observation campaigns using multiple instruments, including cameras, spectrometers, and particle sensors. Coordination with NASA's Europa Clipper is under consideration, particularly for twin ultraviolet spectrograph observations. JUICE is currently on the far side of the Sun, using its high-gain antenna as a heat shield, so data won't return until February 2026, but the observations will happen. December 19th, 2025. Closest approach to Earth, 1.83 astronomical units. Not close by astronomical standards, but close enough for detailed spectroscopy, photometry, and radar observations from Arecibo and Goldstone if those facilities target it. Close enough to see changes, close enough to detect anomalies. March 16, 2026. Closest approach to Jupiter, approximately 31 million miles. NASA's Juno spacecraft orbiting Jupiter will be in optimal position to observe. Juno's instruments include cameras, spectrometers, magnetometers, and particle detectors. If 3I/Atlas releases objects during perihelion, The gravitational influence of the Sun will have separated their trajectories by March. They'll be spread out, detectable as separate entities. These are not arbitrary dates. These are observation windows. These are the moments when telescopes will be pointed, when data will be gathered, when we will have the opportunity to answer fundamental questions. Is 3I/Atlas fragmenting like a natural comet? Is it releasing mini-probes like a technological mothership? Is it continuing on its predicted gravitational path, or is it deviating? What should we look for? What are the signatures that would confirm natural versus artificial origin? Natural comet signatures: progressive brightening followed by dimming as the object moves away from perihelion. Fragmentation into multiple pieces separated by days or weeks of observation, consistent with tidal stress and thermal fracturing. Continued outgassing with decreasing intensity as volatile ices are depleted. Spectroscopic signatures matching known cometary compositions as deeper layers are exposed. Smooth, predictable trajectory following gravitational mechanics with non-gravitational acceleration proportional to outgassing rate. Artificial signatures: stable brightness, inconsistent with sublimation depletion, appearance of new objects in the vicinity, days or weeks after perihelion, moving on non-gravitational trajectories, changes in spectroscopic signature suggesting exposure of different materials or active release of substances, trajectory deviations inconsistent with outgassing, particularly if deviations correlate with planetary positions or viewing angles, geometric patterns in debris field inconsistent with random fragmentation, radio emissions in organized frequency bands. I want to be absolutely clear. I am not advocating for the artificial interpretation. I am advocating for thorough observation and open-minded analysis. Science advances by following evidence, not by protecting comfortable narratives. The history of astronomy is filled with observations initially dismissed as impossible that later revolutionized our understanding. Quasars, pulsars, exoplanets, dark energy, each began as an anomaly that didn't fit existing models. 3I/Atlas is an anomaly, multiple anomalies, and anomalies are where discovery lives. Harvard astrophysicist Avi Loeb submitted a white paper to the United Nations on September 30, 2025, advocating for coordinating global scientific research to maximize observational coverage of interstellar objects. The paper, co-authored with Omer Eldadi and Gershon Tenenbaum, explicitly addresses the remote possibility that such objects could pose a threat to humanity if they happen to carry alien technology. This is not fringe speculation. This is a former chair of Harvard's astronomy department, founding director of the Black Hole Initiative, calling for preparedness. Loeb introduced the Loeb scale, a quantitative metric for assessing the likelihood that an interstellar object might be technological. 3. I/Atlas currently ranks 4 out of 10 on this scale due to 8 anomalies: ecliptic alignment, sunward jet, extreme mass relative to other interstellar objects, arrival time, allowing close approaches to multiple planets while remaining unobservable at perihelion, early activation far from the Sun, indicating volatile rich composition, unusual nickel-iron ratio, high carbon dioxide content, and absence of detectable non-gravitational acceleration despite active outgassing. 4 out of 10. Not a smoking gun, not proof, but sufficient to warrant serious attention. Tom Statler, NASA's lead scientist for solar system small bodies, recently stated that while 3I/Atlas does exhibit several interesting properties, it behaves like a comet, and the evidence is overwhelmingly pointing to this object being a natural body. This is the consensus view. This is the view supported by most observational data, and this view is probably correct. But probably is not certainly. And in science, we don't accept conclusions based on probability alone. We test them, we observe, we gather more data, we remain open to being wrong. Because here's what keeps me awake: the improbability stack, the convergence of low probability events. Each individual anomaly has an explanation. Each can be rationalized, but together they form a pattern that whispers, "Pay attention." Consider Pascal's wager applied to cosmic contact. Blaise Pascal argued we must consider God seriously even if the likelihood of existence seems small, because the implications are enormous. The same logic applies here. We must consider the technological hypothesis seriously, even if the likelihood seems small, because the implications are enormous. This is not about belief. This is about preparedness. This is about intellectual honesty in the face of data that doesn't quite fit. The Galileo project, led by Loeb, tasked its observatories to monitor for unusual activity of extraterrestrial technological objects near Earth in the coming months. Multiple ground-based facilities are watching. Multiple space-based platforms are positioned. If something unusual happens, if mini-probes appear, if trajectory changes occur, we will detect it. But detection requires looking. It requires instruments pointed in the right direction at the right time. It requires people willing to report what they see, even if it contradicts expectations. So here's what happens next. We watch, we wait, we gather data. The universe is about to tell us something about 3I/Atlas. Maybe it will confirm the natural comet hypothesis. Maybe it will deepen the mystery. Either way, we learn. November 11th is when 3I/Atlas becomes visible again in Earth's morning sky for observers with telescopes 8 inches or larger. Not spectacular, not naked eye visible, but detectable, trackable. If you have access to observing equipment, look for it. Contribute observations to the Minor Planet Center. Citizen astronomers have made critical discoveries before. You might see something professionals miss. To stay on the timeline as this unfolds, to receive updates as new observations come in, as images are released, as data changes our understanding, subscribe to channels covering this story. This is not entertainment. This is unfolding science, real-time discovery process. You are witnessing the scientific method in action, watching how we move from observation to hypothesis, to testing, to conclusion. And here's a question I want you to consider, to discuss, to debate. Is 3I/Atlas evidence of contact or evidence of pattern seeking? Are we seeing genuine anomalies that point towards something extraordinary, or are we imposing patterns on random data because we want to find something? Both possibilities are real. Both have happened throughout scientific history. How do we distinguish signal from noise? How do we balance skepticism with openness? Leave your thoughts. Engage with this question. Because the answer matters for how we approach not just this object, but the next interstellar visitor and the one after that. The Vera Rubin Observatory, recently commissioned, will begin operations with unprecedented sky coverage, detecting interstellar objects years before they reach the inner solar system. Within a decade, we'll have a census of interstellar visitors, dozens, hundreds, maybe thousands. 3I/Atlas is not an isolated event. It's the beginning of a new era of astronomy. Think about what this means. Every day, according to recent estimates, there is almost always at least one interstellar object within our solar system. Most are small, most pass through undetected. But they're there. Messengers from other star systems, time capsules carrying information about formation conditions light years away, or, just possibly, something more. We are living through a unique moment in human history. For the first time, we have the technology to detect these visitors. For the first time, we can study them in detail. For the first time, we can ask the question not just, what are they, but who made them? That question, that possibility, that tiny probability weighted by enormous implications is why 3I/Atlas matters beyond its scientific interest. Because somewhere in the stack of anomalies, in the alignment of trajectory, in the chemistry that doesn't quite fit, there might be a message. And if we're not looking, if we're not willing to consider uncomfortable possibilities, we might miss it. So, let me bring this back to the central question, the question that has driven human curiosity since we first looked up at the night sky. Are we alone? The universe contains 200 billion trillion stars. Each star likely hosts planets. Each planet represents an opportunity for life. The numbers are staggering. The probability arguments overwhelming. Somewhere, statistically speaking, there must be others. But probability is not proof. Statistics are not data. Until we have evidence, we have speculation. 3I/ ATLAS is not proof. It is not evidence of extraterrestrial intelligence. It is a comet exhibiting unusual properties that might have natural explanations we haven't yet identified. But it is data, real data, measured, quantified, anomalous, and data is where discovery begins. Right now, at this moment, 3I/Atlas is on the far side of the Sun, bathed in gigawatts of solar radiation, invisible to our telescopes, executing whatever physics governs its behavior. Natural or artificial, random or designed, we don't know. In 2 weeks, it will emerge, visible again, observable, changed or unchanged. We will point our instruments, we will gather photons, we will measure spectra and trajectories and brightness curves, and we will learn. This is how science works, not with dramatic revelations and sudden certainty, but with patient accumulation of evidence, careful analysis, and honest acknowledgement of what we don't yet understand. 3I/Atlas is teaching us about the chemistry of interstellar space, about comet formation in alien environments, about the diversity of objects traversing the galaxy. It is teaching us regardless of whether it is natural or artificial. The lessons are real. The science is valuable. But there is another lesson here, a lesson about intellectual courage, about being willing to look at data that doesn't fit and ask uncomfortable questions, about balancing skepticism with openness, about following evidence even when it leads somewhere unexpected. The terrifying part is not that 3I/ATLAS might be artificial. The terrifying part is that we might dismiss it as natural without sufficient investigation, closing our minds to possibilities because they seem improbable. Improbable is not impossible. Extraordinary claims require extraordinary evidence, yes, but extraordinary evidence requires extraordinary observation. We must look, we must measure, we must be willing to be surprised. Because the universe has surprised us before, it will surprise us again. And when it does, when the next anomaly appears, when the next interstellar visitor exhibits behavior we can't easily explain, we need to be ready. Not with belief or disbelief, but with instruments and curiosity and the willingness to let data tell us what is true. 3I/ATLAS is hiding behind the Sun right now. In 2 weeks, we see what emerges. In 3 months, we track its path past Earth. In 5 months, we watch it approach Jupiter. The countdown is running, the observations are scheduled, the data will arrive, and we will know more. Not everything, but more. That is the promise of science. Not certainty, not final answers, but progress. Incremental, careful, evidence-based progress toward understanding. Are we alone? We don't know yet, but we're looking, we're measuring, we're asking the right questions. And 3I/Atlas, whatever it is, wherever it came from, is helping us ask those questions better. The hidden structure inside this interstellar visitor might be ice and rock formed in exotic conditions billions of years ago, or it might be something else, something that changes everything. We're about to find out.